Hello everyone, I want to thank you for attending today's webinar by Gemtech Group hosted by Raritan. Our presenter today will be Richard. Before we begin, I just want to make sure that everyone can see Richard's screen and hear everything. If you can't, please let us know. And then during the presentation, if you could please keep your phones on mute during the presentation, unless you have a question, that'd be great, so then everybody can hear, we don't have any background noise. Please feel free during the presentation to ask any questions or just wait until the end. And now I will turn it over to you, Richard. Thanks.
Paul, thank you very much. Good morning, everybody. Like Paul mentioned, my name is Richard Brooke. I'm the Senior Technical Trainer for Raritan. It's a pleasure to be talking to you today. What we want to do is we want to talk about deploying high power at the rack. We're seeing a lot of trends out there in the data center, and we've all seen the growth of the data center and what a pain point this has become for a lot of people. So what we're going to do is talk today about some industry trends, challenges we're facing out there, introduction to 400-volt power, three-phase power. This is new for a lot of people. Some other considerations and some reason benefits of what deploying 415-400-volt power at the rack can do for you. So, I've been doing this for a long time. I mean, I'm gonna age myself here and tell you my first gig in this industry was doing Commodore 64 software support. So I've been doing this a long time, and I've been doing data center products now for about the last 15 years. And when I started 15 years ago, I worked for a UPS manufacturer, and we put a 3 kVA UPS in a rack, and that would be fine. And the data center has been this evolving amorphous blob, if you will. It's different every time. It takes different shapes out there. And what we're seeing here is, years ago the expert predict we'd go from a 3 to a 4 kW rack to a 6 to a 7 to an 8 to a 12. And this trend has actually been fairly accurate and growing. And what we're seeing now is huge big data. We're seeing cloud infrastructure. The advent of blades. Now you can put where you can traditionally were limited to 42 1U servers in a 42U rack. The amount of cores and processors you can put in there were just absolutely phenomenal. So we're seeing all these huge servers, and the density of these servers shrink and shrink and shrink. I was just reading an article the other day from one of the chip manufacturers about how we continue with Moore's law to make CPUs smaller and smaller, and the socket and core count just continues to grow. So we're putting tremendous computing power in smaller and smaller places. Actually, one of the flip sides of this is we're seeing a new generation of low energy servers. I did a Linux power user group meeting a couple weeks ago, and these guys had these really almost servers the size of a small shoebox that drew an open source Linux code. Now you can put tons literally into a rack of these servers. But whenever you're doing your condensation, you're condensing these servers, we're drawing more and more power. How do we efficiently learn to power these servers? What methodology can we deploy to make sure these servers are going to have power? And when I do a lot of user group trainings and some trainings out there, it's interesting to hear the server companies talk and the networking companies talk about how their product is the best in the world and everything else. And I always like to start off and say, guys, if you can't power these servers, you might as well have cinder blocks in the rack, because you know what? You need power. And if you can't power these servers, no matter how good your software, your OS is, your networking, your storage, it's nothing without power. So what we're seeing here is also not having power is a bad thing. We're seeing companies that are hitting thresholds. My days of walking into data centers with the CIO, and he may ask one of their, the worker bees in the data center, can you power this? And, you almost see the deer in the headlight look, and they say, I don't know. I don't know if we can power something is not good, because I don't know means I may plug this server in and start tripping breakers. Obviously, that's not a good thing to do. It's not a good thing not to have power to your racks. We've all been, usually it's sometime during an important sports game, and somebody in the house turns on the microwave and trips a breaker, and there goes the TV and half the house. That's not good to do on a data center scale. It's not good to do even on a rack or a row scale. Those servers need to be brought down gracefully, so losing power can be detrimental. Now, we do see UPS failure to be one of the most common causes out there, but there's a lot of factors, the human factor, again, tripping breakers, not having enough power to the rack, plugging something in and shorting everything out. It can be a factor. So it's really important to know your capacity, know if you do indeed have room in this rack to deploy these servers, the storage device, what have you. You know, it's important to measure. If you can't, you know, you need to monitor and measure your power. That gives you control, puts you in command. So traditionally, you know, we used to see a fight from bringing customers in from even 120 into single-phase highline, you know, 208. Now we've seen that fight to bring customers in from 208 into three-phase. And once we, you know, you show them this, the amount of power we can bring in with traditional three-phase, it's kind of amazing. Using our simple math, you know, volts times amps, we're timesing it by 1.73 for three-phase power. We can bring in you know, 8.6 on a 24 amp PDU, 14.4 on a 40 amp KVU, 48 on a 48 amp PDU. We can bring in 7.3 kW, and these are all the derated values. You know, that's of course 60 amp PDU, a 50 amp PDU, and a 30 amp PDU. That's a lot of power. 8.6, 14.4, 17.3. When we start to factor in what we can bring in using 400 volt three phase, now we're taking those numbers and we're doubling them. You know, we used to show customers going from, you know, simple 208 into three-phase. We're giving you a huge advantage. Now we're taking that three-phase advantage, traditional three-phase, and we're bringing a 30 amp three-phase, and we're bringing it up to 400. And you can really, really bring in a huge amount of power to the rack. And we are seeing customers that are delivering that much power to the rack. Again, with blade servers, with consolidation, we've seen customers actually do custom-built 50, 54U racks. With cooling technology increasing too, you can handle, the data center can handle these new high-power loads. You know, we're seeing a lot of customers deploying liquid-cooled racks, spot cooling, chimney systems, outside air economization. So with this new increase in cooling capacity, the ability to deploy a 16.6 kW rack is feasible, it's doable, and people are doing it. So, you know, three-phase power is phenomenal. Now if we can bring it up to 400 volt three-phase, true high power to the rack, it really gives us a lot of benefits that we can deploy that much product, we can deploy that much power, and we know that power is there for future usage. So traditionally, we would see utility power coming in into a UPS. It would go to an on-the-floor PDU transformer, then to a floor PDU or a rack PDU, and then eventually to the rack PDU. Excuse me, when I say row PDU, to the rack PDU. Now, there were a couple bad things here. You had that transformer on the floor. This generated heat. So if we can take a source of heat out in the data center, that's a definite plus. Second of all, we would lose power. Whenever you do a transformation, when you step something down, we're losing our efficiency. You know. So today we're seeing it coming in from utility into a 480 coming in from utility into a UPS that has an auto transformer. Most of the major UPS manufacturers are doing this now, or we're going into a floor/rack PDU, you know, an RPP, not a remote power panel, that has that auto transformer built in, and now we can deliver straight 415 right to the rack level PDU. Anything we can do to help reduce heat on the data center floor, and if we can reduce energy costs, if we can reduce that distribution cost, not having that, you know, 2, 3, 4, 5% loss by downstepping it, that's a plus out there. Any efficiencies we can deliver to the data center, we're delivering such high loads right now, even single-digit percentages can make a difference, and can make a difference in the amount of product we can deploy and what we can deploy as well too. So traditionally, with this is North American PDUs, you know, if you look what we can bring in single phase, you know, we can bring in about a 5 kW load. That worked great a couple years ago. And we're still seeing customers that, you know, do have cooling issues, that don't have that capability to cool a rack over 6, 7 kW. So you know what, if this works, fine. You know, if using a simple single-phase 24/30 amp PDU, you've got, you know, 24 pizza boxes in there, maybe a blade chassis, not much room for future growth. Good. Hey, if it works for you, it works great. And we've seen customers actually kind of have almost a standard deployment schedule where we're going to have a rack that's going to be a medium load, and we're going to have a rack that's going to be a high load to go in different places at the data center. But now, as we see, when we can bring in three-phase delta, we can increase that capability. This is having that talk with customers going from 208 into 3-phase. Hey, we're going from 5 to 8.6. Now we can almost not quite double the amount of servers we can bring into that rack. But once we bring in that 3-phase equivalent, I think there's some interesting comparison here. This is 30 amp 3-phase Y and 30 amp 3-phase delta. Now on the 3-phase Y, we're bringing in 400 volt. If you look at the numbers, 16.6 versus 17.3, not quite the same. However, it's close. It's really, really close to the amount of power we can bring in. So we can deploy maybe 3 less servers out there. We can deploy probably the same amount of blade chassis. I mean, that's all going to vary dependent on the customer's site. But going to 415, going to 400 volt power does have some saving capacities. One of the first things we're going to see here in deploying this is we're going to have a lot thinner copper. There's the copper market is still going up. Copper is increasing in value. It seems every other month I'm on a flight. I get my copy of USA Today and I read some story about, they found some thieves electrocuted by stealing copper out of live wires. They didn't know they were live, and unfortunately, that's not a smart thing to do. So any reduction of copper out there is going to make a huge difference. This is going to help in the end deployment by saving money by utilizing a different gauge wire, and a thinner gauge wire, and bringing that into the data center. One thing we'll talk a little bit about Raritan does is we're very, very good about custom builds. And if the quantity is there, as an example, we might have a deployment where, I don't need a traditional 6-foot plug, 6-foot cord, excuse me. Maybe I'm going to a Starline bus or my whip is right under the floor. We can customize a PDU with a smaller input cord, saving you money. Besides going to a smaller gauge, less copper, we can save money in the data center. So right there, this is one advantage of going into 400 volt. The other advantage we're going to see is in the actual deployment costs themselves. If you've never seen a traditional 60 amp 3-phase PDU, which is a big IEC 309 plug, I mean, this thing is it's big. I actually wish I almost had a little diagram showing how big they are. It's a big honking cord. I think that's the only technical way we can come up with. To deploy the pin sleeve, the plug and the input in this cord is a lot of money. And this is a very, very expensive socket and plug. Versus going to a Hubble plug, it's going to look very, very similar in style to an L630 or maybe an L520, a locking plug. Some of you may be traditional plug that I've used in the past. Doing the deployment on this for the plug and the outlet set, I mean, seriously reduces costs. This makes it so much easier to deploy, and it makes deploying these a lot less expensive as well too. Just to give you an idea, this is a standard 6-foot plug deployment. That's a big delta right there. So a couple of advantages we want to talk about when deploying a true high-power PDU is going to be single pole versus double pole breakers, and actually we're going to also talk about triple pole out there. All Raritan, the Raritan PDUs out there, we deploy either a double or a triple pole breaker. A lot of the competitors out there deploy a single double pole breaker. So if we look at this, we have our line coming in here. These 6 outlets are covered by only one 20 amp breaker. It's very, very easy with 6 plugs. If you think about some of these draws on these servers, we're seeing Cisco switches out there that have 500-600 watt power supplies. If you don't know what you have in that PDU, I start plugging stuff in, I'm going to trip that breaker. It's a joke out there. People see open plugs in a data center. They go, I must have power. The plugs are open. So by having just a single double pole breaker for these 6 outlets, we are almost inviting ourselves to go ahead and trip this breaker. On a Raritan double single pole breaker, we have a breaker now protecting each of these 3 outlets. Right there, you can max that out. It would be difficult, but out there that those breakers are protected. It kind of goes back to that analogy of the breakers in your house. You start plugging everything in and running the microwave and the coffee maker, you're going to trip a breaker. In this example, we've seen customers out there with the lower end PDUs. Hey, I'm just going to plug as much stuff in and surprise, I just tripped a breaker. And again, that's not good to do on a data center level. It's not good to do on a rack level. We want to make sure those servers are brought down graceful. In some instances, we've had customers request actually a triple pole breaker, mostly utilized in blade deployments. Blade power supplies are very, very advanced. However, if they're not set up right, you have the capability, if you bring one power supply down or one power supply's trips, you can have almost a domino theory where you can start to bring whole blade chassis down. We've had some PDUs will have a 3-pole breaker where each C19 plug is now protected by its own 20 amp breaker. This is, I will say, overkill, but you know what? Let's make sure it's done properly. Some customers want to have this out there. They want to have a no-fault data center. There's a way to ensure each plug, each C19, each blade power supply is protected by its own breaker. So that is up to the customer choice of what they want to go with. We do a specific double pole and triple pole breakers, but again, when utilizing this much power, we want to play it safe. Another cost-saving scenario we've seen customers deploy out there are multiple input PDUs. Now in this example, we have this red PDU I'll toy with here. We have 2 different inputs coming in. We don't offer a crossover PDU right now. Raritan does have one in the works. We will have a PDU that have dual feeds coming in where feed A fails, feed B will take over. Right now, this is considered 2 individual feeds, but one of the advantages here is each PDU is sharing a brain. So instead of having 2 different PDUs or 4 different PDUs, depending on your deployment, we have one single or 2 double input PDUs coming in. I said that wrong. We have either 1 or 2 double input PDUs out there coming into your rack or your racks, and that PDU is each sharing a brain, it's sharing the sensor ports out there, it's sharing that common intelligence, so there will be a less expensive price to deploy a multiple inlet PDU because, again, it's sharing those resources versus having a PDU with individual resources. Now, what goes beyond 415? We've had some customers talk about 480, 277, and this is literally coming right from the power plant. One of the problems we see here is your industry standard C19, C13 plug simply won't deploy this. It isn't feasible right now for a what's on the shelf deployment. Facebook, some open computing, they've kind of pushed this because it does give an additional percentage of efficiency at the rack level. However, again, almost everything off the shelf out there, whether it be the PDU, the server plugs, the UPS, the outlets and everything else out there, are not available in an off-the-shelf solution. Is this something we may see in the future? Certainly. The sky's the limit out there when it comes to computing. I kind of throw this out there as a food for thought for people. So I'd like to review the benefits of 400-volt 3-phase. You're going to be able to increase higher power densities. With that, with more power, you have increased capacities. Now you know how much power you have at that rack. Now you know where we can deploy additional product out there. It is efficient power distribution. By removing that transformer, we're removing a source of heat out of the data center, and we're also reducing additional electric transmission costs. Right there, again, this is a cost-saving factor. Lower copper, plain and simple. That is a physical, it's not, in the ethos, like, if you will, saving power by using less copper. That is a physical cost savings out there. Also, the deployment, low amperage plugs, less whips, fewer cable runs, fewer pole positions. Again, this is 3-phase. We're going to be taking up 3 poles on the breaker panel. The more poles you take up on the breaker panel, the more money. So by deploying 400-volt 3-phase, we can save a lot of money at the data center, and we can provide a source of a ton of power. I think that's win-win for everybody. A couple other considerations we want to talk about when talking about PDUs. I talked about heat. As we see core count, processor count go up there, the cost of running your data center, of cooling your data center is huge. I read an article, it was a white paper from one of the chip manufacturers that was talking about the surface of their PDUs are hotter, something like 5 times hotter than the cost of a quartz induction cooking top. So if you think about that, that's a lot of heat. You're paying we've seen numbers that say you pay more to cool your data center than the cost of the servers in your data center. So it's important to have environmentals in your data center. On Raritan PDUs, we can deploy up to 8 temperature, 8 humidity probes. We can deploy airflow, air pressure. It's important to know that you're getting airflow to the right spot. It's important to know in a chimney system, for example, outside air economization, what your air pressure is. So we have that ability off the front of our PDUs to manage our environmentals, report on our environmentals, set thresholds on our environmentals, and keep you in the know when it comes to environmentals in the data center. So the commercial, our PX PDUs are phenomenal, plain and simple. We can deliver from single-phase 120 to 400-volt three-phase PDUs. We can give you metering at the outlet level, the switch level, the circuit breaker level. It's a phenomenal, phenomenal product. We have our EMX product, which allows you to do port consolidation, so you can deploy a suite of Raritan's asset tags, our airflow, air pressure, open contact sensor, water, all of our environmental probes out there. Deploy these in a non-Raritan environment and have the reporting capabilities and everything else from those environmentals. So we think we do the best PDU out there. Again, we can give you any sort of offering you might need. You want single-phase, three-phase, 0U, 1U, vertical mount. We have them out there. Raritan PDUs, we can provide industry-leading amount of data capture. We're going to give you amps and power factor and volts and watts and kWh and VA. Our kWh is billing grade. It's 1% or better, one of the industry-leading highest out there. We put a full suite of features into our PDUs. We have the ability to do a USB daisy chain on them. We can hang a web camera off there. We offer optional Wi-Fi on our PDUs. Our PDUs are also can be put into the Cisco EnergyWise command set. And you know what? If you've noticed, we've seen different colors of our PDUs out there. We have a color palette of different colors out there. We can color code the PDUs. I think it's one of our large customers. You walk in their data center, they have a red feed and a blue feed, and guess what? They have a red Raritan PDU and a blue PDU. Really, really hard to mess that up. So really, we want to be able to provide the industry-leading PDUs out there, and again, whether you want to measure at the outlet level, measure at the circuit breaker, at the breaker, the strip, you want to turn the outlets on, you want to turn them off, you want to power cycle them, you want to always have them on, we have a PDU for your need out there. Please contact our fine friends at GEM. They can recommend a fine Raritan PDU for you. And I'd like to show this slide. We build our PDUs from the ground up. We don't OEM them. We build them. We build one of the best PDUs out there. Going back on the cooling method out there, as we see outside air economization, as we see hot aisle containment, our PDUs are rated to 60 Celsius, 140 Fahrenheit. So the PDU, as we're seeing that delta T rise in the data center, our PDUs are designed to be in that possibly hostile environment, in a containment unit, in a pod, what have you. We can survive in that environment. We build our PDUs. We build them from the ground up. We build the best ones out there. I look at our PDU there, and that's a PDU of one of our esteemed competitors. And I think the old saying, a picture says 1,000 words, and I think that says 1,000 words right there. So we have some additional resources we can give you. We have a white paper that was written on deploying high power to the rack. We also have on our blog how to calculate current three-phase loads on a PDU. We have a full suite of training information out there at raritantraining.com, as well as if there's anything on a technical issue you guys want to talk about, get into, we'd be more than happy to set something up through our friends at GEM. That is today's presentation on deploying high voltage 415, 400 volt at the rack. And I thank you guys for taking the time. I hope this was informative.